Okay, so we're going to look at how we draw these for a converging lens. In this case, it's a double convex, and how we find the image of a double convex. So we're going to follow the same basic rules that we followed for mirrors. There's going to be some subtle changes, and the main difference is with mirrors, light reflects. With lenses, light refracts. So keep that in mind as you make your drawings. So rule number one is essentially the same, which is you're going to draw a parallel line from the object to the lens. Now before, what did we do after we drew our parallel line? We reflected through the focal. And we're going to do the same thing, except we're not going to reflect. We're going to refract. Now there are two focal points. If you just think of the word refract, there's only one possibility of which one. But let me ask it anyway. Is it going to refract through the focal on the same side or the focal on the opposite side? Opposite side. Okay, so you're going to draw a parallel line from your object to the lens. Okay, like this. And then you're just going to refract it. Oh, so one of the differences, or one of the similarities, if you look at the last picture that we just made, the actual beam refracts twice, each on each boundary, right? Here, air to glass, here, glass to air. For simplicity, we're only going to refract it once. So you're going to refract it once from the center of your lens. So that's why we drew that dotted line down the middle. So just refract it once through the center. So line up your ruler with the focal on the opposite side. Okay, draw it on through. So that's beam 1. Alright, what is beam 2 then? What is beam 2? From the object, and then how? Through the focal point. So we're going to follow the same kind of basic rules. Now one of the differences here is we're going to draw a line from the object through the same side focal. And we're going to refract it. Any guesses on how we're going to refract it? Parallel. So draw a line from the object through the same side focal point, and then refract the beam parallel. We're going to go ahead and refract it parallel. Okay, so take your ruler. I also have this written on the board on the side if you can't, when I remove the paper. Oops. Okay, send it through the focal point. This is beam number 2, and then we're going to refract it parallel. Yeah. How come what?
We're refracting our image to make it straight.
Why are we making it straight?
Yeah, like all the lines kind of straight through.
Through the middle?
Yeah.
Oh, so we're doing this just for simplicity and accuracy. In the back of your mind, you should know that it's actually refracting twice. Once, twice, like this. But, I mean, to really do this, you'd have to use Snell's law, you'd have to use a protractor to figure out those angles, and so forth. So, for simplicity, we're just going to refract it once, and we're going to do it right at the center. And so these lenses, we usually call these thin lenses, or that works for thin lenses. So, relatively speaking, there's not much movement distance between here and here.
So your bounce
Towards the mirror, towards the center. We kind of did it with mirrors too. We did a similar thing. Okay, that's beam number 2. So this was beam 2, right? The purple is beam 2, and the black one is beam number 1. Okay? All right, what was the third beam with mirrors? Through the center of curvature. However, with lenses, you do not have a center of curvature. So this rule is completely different, though I'm going to use similar language just to help you remember. So what we're going to do is we are going to use the center, but we're going to use the center of the lens. So draw your beam from object to the center of the lens. Okay, so let me show this for you. You're going to draw an object. Draw a line from your object through the center of the lens. Like this. Now here's what happens. You can kind of see it from this picture. This is going to hit right on the normal. So the way, see the normal's angled and the beam itself is angled, it's going to hit right on the normal. What happens when things hit right on the normal? Doesn't refract at all. It just keeps moving in a straight line. And so that's what you're going to do. You draw your line from the object to the center of the lens. No refraction will occur. Therefore, just continue the line. So you're not going to refract the beam at all. You're just going to let it keep going. Don't have it bend at all. In fact, when you draw it, you shouldn't even stop like I did. Just keep it going all the way through. Okay, so this green beam should be line 3. Alright, and if you do it correctly, you should have a nice 3-way intersection on the opposite side. Remember, this point represents the tip of the arrow. So notice what happens to my arrow. Again, it's underneath the axis, so it's now flipped upside down. And that would be my image. What do you notice? What are some characteristics about this image? It's inverted, smaller. And what do you think about this image? Is this a real image or a virtual image? This is actually a real image. This is a real image. The reason it's real is if you look at it, all the light converges at a point. So all the light focuses. So there's actually light over here. And if I put a screen, if I take a piece of paper and like put a screen right here, it's going to show up on the screen. There's going to be an image right there. Okay? So that means that this is a real image. Anytime light converges together, forms a real image here. Let's go ahead and make some measurements. Let's see how good our drawings are. So I'm getting a DI of about, looks like about 4.8. Getting an HI of about 1.7. Hopefully you guys are getting something close. Okay, let's do the math. So guess what? The equations are the same. Okay, we have the lens equation, we have the mirror equation, and they're the same thing. So we'll just use the same equation. So 1 over F equals 1 over DI plus 1 over DO. So let's see how close we got. 1 over 3 equals 1 over DI plus 1 over 8. What do you guys get for DI? 4.8. Okay, let's do H. Same equation. HI over HO, negative DI over DO. Don't forget that negative is important. HI over 3, negative DI, negative 4.8 over 8. What are you guys getting for H? Negative 1.8. Okay. And again, what's that negative mean? Inverted. And lastly, let's get our magnification. M is how much? Again, the negative means it's inverted, and then what is the 0.6 telling us? So I do want to point out some similarities and differences with lenses and mirrors. First of all, these are all the same. The meaning of magnification, the meaning of negatives, smaller or larger, is the same. There is a slight difference here. With a mirror, when you got a DI of positive, where was the image located? On the same side of the mirror. Okay? For the lenses, when you have a positive DI, it means it's on the opposite side. So that is a difference. Positive, negative distances mean different locations. Okay,